Imagine a world where something can exist in two places at the exact same time. Sounds like science fiction, right? But what if we told you that this isn't just a thought experiment, but a fundamental principle of reality, observed in the smallest building blocks of our universe? Welcome to the mind-bending realm of quantum superposition, where particles defy our everyday logic. Our journey begins with the famous double-slit experiment, a cornerstone of quantum mechanics. When we fire tiny particles, like electrons, one by one at a barrier with two slits, something extraordinary happens. Instead of two distinct lines, as you'd expect from particles, we see an interference pattern on the screen behind the slits. This pattern is characteristic of waves, like ripples in a pond, passing through both openings simultaneously and interfering with each other. It suggests that each individual electron, somehow, behaves like a wave and passes through both slits at once. This phenomenon is called wave-particle duality, where quantum entities exhibit properties of both waves and particles. But here's where it gets truly bizarre. If we try to observe which slit the electron goes through, the interference pattern disappears. The act of observation forces the electron to choose a single path, collapsing its wave-like behavior. This leads us to quantum superposition, the idea that a particle can exist in all possible states simultaneously until it's measured. It's like a coin spinning in the air. It's neither heads nor tails until it lands. For a quantum particle, spinning means being in multiple locations, having multiple energies, or even multiple spin directions all at once. A classic analogy is Schrödinger's cat, a thought experiment where a cat in a box is simultaneously dead and alive until observed. While a real cat can't be in superposition, it helps us grasp the counterintuitive nature of the quantum world. This bizarre property isn't just theoretical. It has profound real-world implications, especially in quantum computing. Traditional computers use bits, which are either 0 or 1. Quantum computers use qubits, which can be 0, 1, or both simultaneously. This allows quantum computers to process vast amounts of information exponentially faster than classical machines. From developing new medicines to breaking complex encryption, quantum superposition is paving the way for revolutionary technologies. The universe, at its most fundamental level, is far stranger and more fascinating than we could ever imagine. Quantum mechanics challenges our very perception of reality, pushing the boundaries of what we thought was possible. Want to dive deeper into the mysteries of the quantum world and beyond? Then make sure to like this video, subscribe to our channel for more quantum wonders, and comment below with your mind-blown emoji.